Welcome back to another episode in learning about the LEGO Mindstorms EV3 system. In this episode, we're going to talk about how to use encoders, which are components on your LEGO motors that will count how many rotations it rotates. Um, the program will use encoders to try to help make your robot drive straight. Now, in engineering, this is the concept of feedback control systems, and we're probably going to have a couple episodes just talking about it at a conceptual level so that students at this sort of age can understand. For now, let's assume that you have downloaded the straight.ev3 project. So we'll open it up. And first, let's just implement it. Let's put it into your program, or I should say project. So I have a new project here. And in this straight.ev3 file, we're going to talk about what this all means, but we're going to go to the wrench. Usually it's on programs. You're going to go to My Blocks, click on that, copy, go over to your project, same thing, the wrench, the project properties, go to My Blocks, and paste. And with that, you'll see that in the 6th tab, this straight drive block is ready to go. Now, I probably should have shown you before I imported it, before I copied and pasted, there were no My Blocks. And My Blocks are a way to create your own functions. In more complex programming languages, you can create a set of instructions and encapsulate it in a function. So you don't have to copy and paste the same code every time. This block, let's just explain the inputs here. You say drive straight for how long, then at what speed, and then this adjustment or gain factor, GAIN. And so long as your project has this My Blocks, you're ready to go. Okay, so what exactly does this My Blocks do? Well, we can take a look at the straight.ev3 file to understand. Because you've downloaded this project file, you will have all of this. Do know that the first two programs, they're just a basic straight drive moves, just so you can see naturally how your robot moves. And as you know, there is a move steering versus move tank. And maybe I'll just do a little aside here just to make sure you understand this. Move steering says you set a certain value. 0 is straight. You go one direction. It'll move really tight the other way and really tight in the opposite direction. With move tank, it's a different way to get the same behavior. If both of your motors are the same, then they're going to move straight, or they should move straight. And then you can adjust the values to make it turn. And then, of course, if you go opposite, even more greater of a turn. And remember that your motor should be plugged into the correct ports. Conventionally, B and C are your drive motors. Now, you can test this out to see how well your robot drives straight. And as I mentioned at the beginning, the idea of feedback control systems, this is a whole nother concept. And then actually just driving straight. Robots can't drive straight. You need some sort of feedback system because things are inconsistent. Things are not perfect. Two motors are not exactly the same, and then two pieces of your terrain, your road, are not exactly the same. Okay, let's dive into this straight drive, all right? It has all been commented, but I'll walk you quickly through it. I have to give attribution here to the awesome Builder Dude 35. He's a student who put so many resources online as he did FLL, and actually all of the resources that helped him get into college, and he's actually at MIT now doing this sort of thing. All right, let's dive into it. If you know from some of our previous lessons, for the beginning learners, we only use green and orange blocks, but now we are going to use the yellow and red blocks, and I think this is a good scenario to introduce them. So we're going to start off, we're going to reset the encoders, all right? And you can imagine the motor may be at some particular orientation of 360 degrees. So this is just saying, hey, reset the value. We don't care where it's at. We're going to start measuring. Now, this next part over here, this is all in a loop. Remember, this is a concept that is difficult to understand at first. This is looping faster than we can perceive, okay? But we're slowing down time, and this is what we're going to do. We're going to say, hey, we're going to measure the rotation. How many times has motor B rotated? And then C, the encoder is built onto the robot. And we're going to take this red block, all right? If you go down here, you know that red blocks are data operations, basically arithmetic. So we're going to say, hey, we're going to subtract one from the other. Now, it's a little confusing because this says A and B, and then this says B and C, but just follow the lines, okay? So it's going to measure the difference between B and C values. And that equals, that's going to get fed into here. If the difference is non-zero, then it is multiplied by the gain. Now, really, it will still be multiplied the gain, but if you know that the difference is 0, meaning the motors are rotating exactly the same amount, then 0 times anything is 0. So that's what I mean by here. And then this answer is fed into a steering block. And if you remember from earlier, with our steering block, all right, 0 means straight, and then anything else is some type of curve. So you can see here that the product of the difference, which is here, times the gain, which you set, okay, and we'll go down here, okay, you set that here, gets fed into the steering. So if that is 0, then it's going to move straight. If not, then it adjusts. So you can just imagine if we had a robot in front of us and then one wheel is just slightly moving slower or faster than the other, that difference is going to get picked up, multiplied by our gain, and then the robot is going to adjust in a certain direction. And then it does it all over and over again. And so really the last part is to say for the gain factor, it's something that you have to test. So start with 1, and the larger the value, so again, the larger the value here, then the greater the difference is going to, it's going to amplify the effect. So simply said, you're sort of overreacting to that difference. But if 1 is too much, then you might want to set that value to lower. Finally, how do we know when this loop will be broken? All right, what is the end condition? Well, it's set by the seconds, the time that's fed from here. And this is just basically saying I want to move straight for 4 seconds. All right, and then of course you stop at the end. So that's what this does. Hopefully that gives you some sense of what you're using. Creating your own my block is a whole different discussion, but hopefully this can at least get you a block that can use the encounters so that you can drive more straight than you would without the encoders. Thanks for listening.